Okay, here's a thought experiment for you. What if one day the sun just vanished?
Poof, gone.
Exactly. The scale of that, it's almost impossible to really wrap your head around, isn't it?
The heart of everything we know.
Mhm.
Just switched off.
So today on the deep dive, we're doing just that. We're looking at a hypothetical, but, scientifically grounded scenario. What actually happens if the sun disappears?
Right. We've pulled together some research that walks through it almost like a timeline of events for Earth, step by step.
And our mission for you listening is to kind of give you the shortcut to understanding this really complex, really high-stakes idea.
Yeah, there are some genuinely surprising bits in here about how space works, cosmic mechanics, and honestly, how stubborn life can be.
So where do we start? The sun vanishes. What's the very first thing? Do we see it? Feel it?
Well, this is the first mind bender.
Sure.
For a full 8 minutes and 20 seconds, nothing.
Nothing.
Earth would be completely oblivious, birds singing, oceans look the same, cities are buzzing along, as if nothing happened.
Why? How does that work?
It's simply the speed of light. Light travels incredibly fast, sure, 300,000 kilometers a second, but the sun is far.
Right, about 150 million kilometers away.
Exactly. So it takes that light just over 8 minutes to make the journey. For those first few moments, we're literally running on stored sunlight, on borrowed light.
Borrowed light. Wow. Okay, so the 8 minutes and 20 seconds are up. Then what?
Then the light runs out. And it's not like a sunset, not a gradual dimming.
No twilight.
No. The sources describe it as immediate, a pitch black silence, like someone just flipped a switch on the entire sky, a terrifying void.
Instantly dark. And the immediate effects on Earth systems.
Oh, they'd kick in right away. Solar panels, useless. Satellites lose their main guide star.
And photosynthesis.
Stops immediately. That engine for, most life on Earth just cuts out.
What about temperature? Do we freeze instantly?
Not instantly freeze, no, but you'd feel it pretty quickly. A noticeable drop, maybe a few degrees Celsius within that first hour or so.
Okay, just the start of the cooling.
Precisely. It signals the beginning of a much, much bigger deep freeze.
And it's not just the sun we lose from the sky, right? The moon.
Visually, anyway. It only shines because it reflects sunlight. No sunlight, no moon. Just absolute, unimaginable blackness at night.
Can you imagine the panic? Airports would grind to a halt. Power grids would likely start failing.
Global stock markets would crash instantly. Total chaos.
But the sources say even that chaos, as huge as it sounds, is kind of small potatoes compared to what comes next.
Yeah, those are the immediate sort of societal breakdowns. The truly existential stuff starts happening on a cosmic level.
Okay, so the darkness hits after 8 minutes because of light speed. What about gravity? Does the sun's pull also take 8 minutes to disappear?
Now that is where it gets really interesting and honestly a bit weird.
How so?
Unlike light, gravity's effect, or the lack of its effect, is instantaneous.
Instantaneous. So the moment the sun vanishes, its gravitational pull on Earth is just gone.
Exactly. That tether holding the whole solar system together, it just snaps instantly.
Wow. So does Earth just stop?
Mm-hmm.
Or what happens?
It doesn't stop spinning on its axis. That's inertia for you. Think of a spinning top. It keeps going.
Right, keeps spinning.
But our orbit around the sun, that becomes meaningless without the sun's gravity holding us in place.
So we don't follow the curve anymore.
Nope. Earth just starts moving in a straight line. It flies off tangent to where its orbit used to be, drifting silently into deep space.
The drift. And the moon, does it fly off on its own?
Good question. For now, at least, the moon is gravitationally tied to us, to Earth, so it would come along for the ride, our companion in the drift.
Okay, so we have our moon, but we're hurtling into the void. Are there other immediate gravitational effects?
Yeah, subtle things, but profound. Tides would go haywire without the sun's influence, combined with the moon's pull changing relative to, nothing. Ocean currents might effectively freeze mid-flow eventually.
And the Earth's axis.
It would likely start to wobble a bit more, unmoored from that stable solar alignment we've always had. And visually,
The star.
as we drift further and further away from our starting point, the night sky itself would begin to look wrong. The constellations, those familiar patterns, would slowly distort as our perspective changes.
A sky that looks wrong.
Yeah.
That's deeply unsettling. So we're drifting, spinning, getting colder. This deep freeze sounds like the next big chapter. How bad does it get?
It gets bad, and it gets bad fast. Within just 1 week, the average surface temperature is predicted to drop below minus 18 degrees Celsius, 0 Fahrenheit.
Minus 18 in a week. Oceans freezing over.
Starting to, yes. First the surface, creating a layer of ice. But over time, that ice layer gets thicker and thicker, eventually freezing the ocean solid, maybe miles deep.
Long term, say a year out.
Within a year, you're looking at an average surface temp of around minus 73 Celsius. That's minus 100 Fahrenheit.
Minus 73. At that point, what happens to the air itself?
Our atmosphere starts to suffer. It would begin to condense, parts of it freezing solid. Carbon dioxide would freeze out first, snowing down, turning the sky maybe a hazy white. Eventually, even oxygen and nitrogen could liquefy or freeze. The atmosphere collapses.
So survival means going deep underground.
Absolutely. Any human survivors would have to retreat far below the surface, their only hope for heat and power. Things like nuclear reactors, tapping into geothermal vents.
Maybe fusion prototypes, if we had them working.
Possibly. The sources paint this picture of, well, underground cities, basically. Cold, metallic bunkers.
Growing food, how?
Lab-grown, under intense artificial lights, probably LEDs. Everything would need to be recycled meticulously.
It really underscores our total dependence on the sun, doesn't it? Mm-hmm. Oxygen levels would drop without plants. Mm-hmm. Agriculture, gone. Pollinators, gone.
And the energy situation. The research calls it Earth entering irreversible debt.
Irreversible energy debt. What does that mean exactly?
It means without the sun constantly pumping energy into the system, everything becomes a finite resource being used up. Every bit of heat generated, every calorie consumed, it's drawing down a bank account that has no more deposits coming.
It's a one-way street to depletion.
Completely. Civilization as we know it collapses. The sources describe it almost poetically. Slowly, quietly, and with dignity.
Grim. But life.
Yeah.
Life finds a way, right? We know some organisms are incredibly tough, like extremophiles.
Exactly. That's the shift in focus. Life is stubborn. Bacteria, archaea. These things have survived asteroid impacts, ice ages, you name it. Total darkness wouldn't wipe everything out.
Where would they survive?
The deep ocean is key. Think about hydrothermal vents on the ocean floor. Those ecosystems.
They don't use sunlight anyway.
Precisely. They never depended on the sun. They use chemosynthesis. They pull energy from chemical reactions using things like sulfur, methane. That's their sunlight. Those ecosystems would likely barely notice the sun was gone.
So life goes on deep down. But on the surface, or even for humans underground, it's a different story. Photosynthesis gone in weeks.
And for humans, it's not just the cold or lack of food. Our own biology is tied to the sun.
Circadian rhythms. Our internal clocks.
Completely thrown off without the day-night cycle, you'd see massive spikes in sleep disorders, psychological breakdowns, not to mention the physical stuff like severe vitamin D deficiency. Our bodies need that solar cue.
So could humans adapt? Could we survive long-term in those underground biolabs?
It's a huge question. The sources suggest maybe isolated pockets, yes.
Yeah.
Sustained by artificial light, maybe algae tubes churning out oxygen, constant water recycling.
Like tiny artificial Earths, fake ecosystem.
Pretty much. Little artificial suns, LED lamps mimicking daylight. It'd be the last flicker, really. The species trying to replicate the star that abandoned it.
It really pushes the question. What's the absolute minimum needed for our kind of life to persist?
And it highlights just how critical self-contained closed-loop systems would be, recycling every atom, every drop of water.
Okay, so Earth is drifting, frozen, maybe with tiny pockets of human life underground, and thriving extremophiles deep in the ocean. What's its ultimate fate? Just drift forever.
That's the most likely scenario, according to the research. Just an endless cold drift through interstellar space. Unless, by some incredibly remote chance, it has a cosmic encounter, a collision with a rogue planet, maybe gets captured by another star, or even less likely, encounters a black hole.
The chances are tiny, but not zero, as they say.
Not zero. But realistically, we're talking vast timescales and immense distances.
And we certainly don't have the tech now to, say, steer Earth towards a new star or capture it in a new orbit.
Oh, not even close. Finding a suitable star, navigating there, somehow breaking and capturing this entire planet. It's pure science fiction for us currently. Puts our limitations in perspective.
Though the sources do mention those far future ideas, right? For incredibly advanced civilizations.
Right, the theoretical stuff. Terraforming moons, building Dyson spheres around a star to capture all its energy, maybe even creating artificial suns with fusion.
Possible, maybe, in theory, someday. But absolutely not where we are now.
Nowhere near. It underscores how precious and perhaps fragile our current situation is.
And it leads to another thought. If this could happen to us, maybe it's happened elsewhere.
That's a chilling but compelling idea in the sources. Perhaps other planets suffered too. Maybe, just maybe, we wouldn't be alone in that kind of darkness.
Alone or not, Imagine being one of those underground survivors. The memory of sunlight.
It would become myth, wouldn't it? Stories passed down, whispers in the bunkers about a time when the sky was blue, when there was warmth from above.
People painting images of the sun on cave walls, maybe? Tales of golden light, green plants, light itself becoming legendary.
A powerful testament to what we lost, how central it was to, well, everything.
What a journey we've just taken, mapping out this deep dive into cosmic disruption. It really highlights the delicate balance, doesn't it?
Absolutely. How everything is connected, light, gravity, life, energy. Change one major piece, and the whole system transforms in ways that are hard to fathom.
It's sobering, for sure. But also kind of amazing to think about the sheer tenacity of life, even in the most extreme conditions imaginable.
And who knows? Maybe, just maybe, after drifting for millennia, Earth finds a new dawn. Maybe it encounters a new star.
Or perhaps a civilization born in the cold and dark eventually finds a way to ignite its own sun.
Because the sources remind us, even without the sun, the Earth never stopped turning. Life in some form might just endure.
Definitely gives you a new appreciation for the sunshine hitting your face today and the gravity holding your feet to the ground. Something to think about.